What is receptive field in CNNs? Imagine you are looking at a beautiful painting. At first glance, you see the entire artwork, but as you focus on specific details, you begin to appreciate the brush strokes and colors. This idea is similar to what happens in convolutional neural networks, or CNNs, when we talk about the receptive field. In CNNs, the receptive field is the specific area of the input image that influences a particular neuron or feature in a layer. Think of it as the portion of the image that a neuron sees when it produces its output. In the initial layers of a CNN, neurons have small receptive fields, often covering just a few pixels. These early neurons are responsible for detecting simple features like edges, colors, or textures. As the data moves through the deeper layers of the network, the receptive fields grow larger. This allows neurons to gather information from wider areas of the input image. With this expansion, the network can recognize more complex patterns and shapes. Eventually, it can identify entire objects or scenes by combining the simpler features detected in the earlier layers. The size of the receptive field is important because it affects how much context the network considers when making predictions. If the receptive field is too small, the network might overlook important parts of an object, leading to incomplete or inaccurate recognition. On the other hand, if it is too large, the network might include irrelevant background information, which can confuse the model. Designing CNN architectures requires balancing the size of the receptive field to fit the task and the scale of objects in the images. Techniques like adding more convolutional layers, using pooling layers, or applying dilated convolutions can increase the receptive field without significantly raising computational costs. This is particularly useful in tasks like semantic segmentation, where understanding the full context of each pixel is essential. Understanding receptive fields also helps explain how models like ChatGPT, DALL-E, and Midjourney process data. While these models use different architectures, the principle of focusing on relevant input regions to build complex representations is similar. In image generation or editing plugins, knowing how receptive fields work can help optimize models to capture details and context better, improving the quality of AI-generated content. In essence, the receptive field in CNNs is a key concept that illustrates how local features are combined and expanded through layers. This enables machines to understand images at various scales and complexities, playing a vital role in many artificial intelligence applications in computer vision.